Hey everyone, I'm gonna talk to you about some thermochemistry today. So to start off, let's define thermochemistry. Thermochemistry is a study of changes that happen during chemical reactions and changes in a state. For example, a change of state is a change in ice. As it melts, it becomes to water. In this example, a solid phase is changing into a liquid phase. So one of the most important concepts of thermochemistry is heat transfer. So heat transfer is the movement of an energy from a hotter object to a cooler object. So as you can see, an example of heat transfer is when boiling water transfers heat to a cooler potatoes that submerge in water. On the other hand, specific heat capacity, which is represented by capital C, is the amount of heat needed to increase the temperature of 1 gram of substance by 1 degree Celsius. The specific heat capacity of a substance is more commonly called the specific heat. For example, the specific heat of water is quite high, as you can see by the water specific heat below, which means that it takes a large amount of heat to raise temperature of a sample of water shown here. For example, water specific heat is 4.18 joule per gram C. So to move on, I'm going to talk to you about system and surroundings and their differences. So a system is a part of the universe that you want to study or focus on. On the other hand, the surroundings are everything else in the universe outside the system. To clarify, for any given experiment, the scientist is the one who chooses the system that he or she wants to study. So now let's talk about endothermic compared to exothermic processes. So the definition of the process depends on which system you'll be focusing on. In an endothermic process, the system gains heat from its surroundings, as you can see. In comparison, an exothermic process includes a system releasing heat to its surroundings. So now let's go back to our example regarding the cool potato being submerged into the boiling water. In this case, because the potato is gaining energy from the boiling water, the potatoes warm up and is therefore an endothermic process. So now we can introduce a very important equation that shows heat transfer to and from an object. So the equation is Q equals M capital C delta T. Or for fun, a lot of chemistry students like myself, you could say Q equals MCAT. So we already discussed specific heat earlier on in the presentation, but the M equals mass in grams of the substance being studied. The delta T is a change in temperature, which is final temperature minus initial temperature. So if the system is heated up during the process, the delta T would be a positive number. The Q in our equation represents the heat energy transferred during a specific process we're focusing on. The value of Q can be positive or negative depending on the delta T. For example, if delta T is a negative number, which means it's an endothermic process, that means the value of Q would also be negative. In other words, if the value of Q is negative, then the system is dropping in temperature and the process is exothermic. So for the last part of this explanation, I'm going to bring you back to the potato example. So the potato, as I have reinstated, the potatoes are cool compared to where they're being submerged, which is boiling water. Our system is the potato, and the surroundings are the boiling water. So we can measure the mass, m, of the potato in grams before it's submerged in the boiling water. So when it's not in any liquid. So to measure potato before it's submerged, which is the initial temperature by a thermometer, we can also measure the final temperature of potato after preferred time frame, maybe when it's cooled off or whenever you'd like. We can also have an approximate number for the specific heat capacity of potato C. So finally, we can calculate the heat transfers, which is Q, in our experiment. Finally, since the potato will be getting warmer in our experiment, we can say that the delta T is positive and Q will also be positive. But now let's jump into Le Chatelier's principle. So here's Le Chatelier, and he created a principle. So his principle pretty much describes how a chemical system responds to some type of stress when it's disturbed. But today, we're going to talk about 3 types of stress. So one type of stress is changing the volume of the system, which can either increase or decrease. Another stress I'm going to be telling you about is a change of concentration of one of the chemicals in a system, which can increase or decrease. Another stress we're going to talk about today is a change of concentration in type of system. What I mean is that it will be increasing or decreasing the amount of the chemicals in the system. But lastly, I'll be covering temperature that can increase or decrease in a system. But for now, I'm going to be showing you an example of how to use Le Chatelier's principle at hand. So here's our equation. So the first term shown is capital N with subscript 2, which means 1 molecule of nitrogen. The second term, 3, capital H, subscript 2, which means 3 molecules of hydrogen. To the right of the arrows, right here, 2NH3 means 2 molecules of ammonia. As you can see, an ammonia molecule is composed of 1 nitrogen and 3 hydrogen atoms. The term 91Kj, to the right of the addition sign, means 91 kilojoules of energy that are being released as a result of the chemical reaction. The items to the left of the arrow are reactants of our chemical reaction. So all chemicals in our reaction are gases. On the contrary, the items on the right side of the arrow are the products. So, as you can see, the arrows are kind of interesting, but I'll get to that in a second. The arrows going between both sides of the reaction are kind of like a balance between 2 sides, so the left and the right side. In general, the principle says if a stress change or a change in a system happens, then the system will shift to the direction of the chemical reaction, which can either be left or right, to relieve or lessen the stress on a system. But for now, I'm going to go over some example problems. So, what's being asked is, what happens if the concentration of ammonia, which is NH3, is increased in the system? So, if the concentration of ammonia is increased, then the amount of products will increase in our reaction. So, the system wants to lessen the increase in the products by shifting the reactions to the left, as you can see. The products on the right side are consumed to make more reactants. So our second example is what happens if the concentration of H2 is decreased. So as you can see, H2 is one of our reactants. Because H2 is decreasing, which means going down, the system wants to restore the amount of H2 on the left side of the equation as shown. So in order to do this, the system will have to push reaction towards the left. So here's our third example I'll be covering. So our third example asks us what would happen if we increase the volume of our system. So if the volume is increased, then the chemical reaction will shift to the side that makes more gas molecules. So in this case, there are more molecules on the left side than the right side, as shown. So our system by Le Chatelier's principle will shift the reaction towards the left because there are more molecules on the left side than the right side. So here's our final example of Le Chatelier's principle. So we were asked, how will our system react if the temperature was decreased? So before I get to that, I would like to tell you that there's 91 kilojoules on the right side reaction, which is energy released by your chemical reaction. So in other words, the heat energy of the chemical reaction is released as a product of the reaction. If we decrease the temperature of the system, it is as if we're decreasing the energy released by the system. If the energy is decreased, as if one of the products reactions is decreasing, so therefore the system will shift the chemical reaction to the right, which is kind of different than all the other problems we went over that said to the left. So, and it's going to the right in order to restore the amount of products. Thank you for watching.